Hello everyone, it's Wilson here. Today I want to talk about how to solve a linear system by using row reduction. This process is also usually called a Gaussian elimination. And what happened is that we write this system of linear equations into an augmented matrix, which will look like this, which is something that I'm going to show right now. So we can, let me first label the equations because I just want to refer to them. We are actually not going to be using those symbols in the calculation here, but then I just want to say that, okay, so that's equation 2, that's equation 3, and so on. So first, what we do is that we can write this system in the augmented matrix form right here. So what it looks like, it's going to be just taking the coefficients that we have, right? For each of the variables x, y, z. So you have x with a coefficient of 1, right? So you just put the 1 here. And then now, as you can see in the first equation, there is no y. So that means the coefficient for the y will be 0. So for the second column here, we are going to just put a 0 here. And then the coefficient for z is 1. So just put the 1 here. Okay. And basically, you can just think of that as the variables x and then y and then z. Is that okay? So each column represents a variable, and so you can say that that's the coefficient for the x for the first equation, coefficient for y for the first equation, and then coefficient for z for the first equation. Now the second row actually represents the coefficients of the x, y, z in the second equation. So we are going to put them here, which is 1 and then -1 and then 2, as you can see. The y has a minus sign in front of it, right? So we do need to include the sign. So make sure that you put the -1 in front of the y, and then put the -1 right here in this entry. So now for the third equation, we have 4, -1, and then -1. Okay, so that's the matrix setup. And then to put it as an augmented matrix, what we do is that we are going to just make a bar here. Sometimes you will see that your textbook may not be putting the bar here. I actually personally find it's easier to work with the bar, even though it's extra work. It's really because sometimes it's easy to forget, okay, so that last column that we are putting right here is actually not part of the coefficients. They're not coefficients. They're actually the numbers that you have on the other side of the equal sign. So we have the 4 here, the 9 here, the 3 here. Okay, and then we simply just put down the bracket. Is that okay so far? So that's how you turn that system into an augmented matrix. So now what we're going to do is that we are going to do Gaussian elimination or row reduction on this one. We can also do Gauss-Jordan elimination, which is really, for this example, just one more step. But then I will talk about that later. So right now we are going to just start doing row operations, performing row operations. Our goal here is to turn this matrix, right? Our goal here is to turn this matrix here into a matrix of the form that's called the row echelon form. And so what happened is that we are going to use this, what we call the pivot, and you can also think of that as the leading coefficient. We want to use this entry right here. And what we want is that we are going to use this entry to remove those numbers. When I say remove, I'm talking about using the entry, and so that we can do a row operation to turn that entry, the first entry in the second row, and also the first entry in the third row into 0. So that's what we're going to do here. Now, how do we do this? It's this. We got to start writing the row operations. Let me start doing it right here. Okay, so I'm just going to use just an arrow here just to indicate the row operation. Now, what we want to do is that we want to use the 1 to remove this 1 to turn it into a 0. So you may say, how do we do that? We can multiply this first row. So this is the row 1, right? So we can, let me just label it first because I think that's really important to remember. Yeah, so this is row 1. So we use R with the subscript 1 to indicate that's row 1, that's row 2, and then that's row 3. Is that okay? Now, what we want is that we are going to use row 1, right? And then multiply by -1, so that entry will turn into a -1, right? Actually, when you multiply row 1 by -1, all the entries in row 1 will turn into, will have to be multiplied by -1. Okay, so we are going to just write negative or 1. So what are we doing? Just multiply the whole row by -1. And then you are going to add to the second row. Okay, so add to the second row. Then what do we do? Then there is another arrow that we got to put here, which is to indicate what row that you're going to make change to. So even though we are multiplying row 1 by -1, we are not going to change the row. Okay, so what happened is that when I write down the matrix, I'm still just going to copy exactly the same thing for row 1 here. I'm not changing it. Okay, so just keep that row. So let me put down the ball here, and then also the 4 will stay. Okay, so as you can see here, I do not change that even though I'm multiplying it by -1. And what I want to do is that I'm adding to row 2. So I'm adding whatever result that I get by multiplying row 1 by -1 and add to that row 2. And then I'm only going to make changes to all 2. Is that okay? That's the only row that's being changed. So now, if you want, you can actually make a note on the side just to tell you what it looks like. So if you multiply, let's say if you multiply row 1 by -1, then you're going to get -1 here, you get 0, -1, and then -4. Is that okay? So what we are going to do is that we add those numbers to those numbers in the second row. So -1 plus 1, we will get 0. Okay, so we will get 0 right here. Okay, and then 0 plus -1, we still just get -1. And then -1 plus 2, we'll get +1. Okay, and then -4 plus 9, we'll get +5, right? This is okay. That's how we are going to do that. Yeah, so again, this arrow, whatever that's coming after this tiny arrow right here, that's the row that you gotta change. Whatever operation that you do to row 1, you actually don't change your original row. Just leave it there. Is that okay? This is one of the common mistakes that I usually see from students' work when it comes to exam times is that they change this row also, which will just add more work to your solving. Okay, now what I want to do is that I'm going to erase those numbers right here because I actually don't need them. When you do more and more, you actually don't even need to write them out, but I'm just showing them here because this is my first video showing how to do row reduction. What happened is that you can also do 2 row operations at the same time in one step. Yeah, you don't have to do 2. You don't have to do like separate them into 2 steps. Sometimes that's what the textbook will show in general, but I would say that it's you as long as they don't get into each other's way, you can actually do this. You can actually also remove the 4 at the same time in the step because you only use row 1 and then you change that 1 into a 0, right? That's what you did for the first row operation. We can do another one because you're still using row 1 here, and then you're going to do something to row 1, and then you need to add that to row 3 so that you can turn the 4 into a 0, and that's not going to be getting in the way of the second row, so we can do that. Okay, so what do we do here? We are going to write another row operation. Now you may have seen the idea from the first row operation. We got to turn this number because it's a 1, so we can actually turn it into any real number by multiplication, right? So you can just multiply it by -4, which will be the opposite of this 4, right? So and then when we add to the 4, we get 0. So multiply this by -4. I mean multiply the whole row by -4. So we get -4 R1 and then plus R3 and then change R3. Okay, so again, we do not change we do not change the row 1. We are changing the row 3 here. Is that okay? So we change the row 3 here. So now what do we get? If we take this, multiply by -4, then we are going to get -4, 0, -4, and then what is that? That's 4 times -4, -16. So now we add all those green numbers to the third row right here, and then we are going to put the result right here. So -4 plus 4, we get 0. 0 plus -1, we get -1. -4 plus -1, -5. Okay, -16 plus 3, we get -13. Okay, so we don't need those numbers anymore. So now basically we have done 2 row operations in one step, and then now those 2 entries below this pivot are all zeros. Now the next one is that we got to use this one as the pivot, because this is the non-zero, the first non-zero entry in the second row. First thing is that we can turn it into a 1. You actually don't have to, but then just to make it more convenient to do the next step or the next steps, then you can just multiply this by -1. Here's another valid row operation that you can do, which is to simply just multiply a row by a non-zero constant. Okay, so what are we doing here? We multiply row 2 by -1. So that's the notation that we're going to use here. Yeah, different books are using different notation, so you can simply just follow the book, or you can use mine, right? So now I don't change the other stuff, right? So I'm just going to keep it as just copy, and then 0, -1, -5, right? And then put the bar here. Then I copy down the other entries, so 4, and then -13, right? And then yeah, so I'm going to use the color right here. So multiply by -1, so you still get 0. Multiply that by -1, we get +1. Multiply by -1, we get -1. Multiply the 5 by -1, we get -5. Okay, so the next step is to just get this entry, right, to become a 0. So what do you do that? How do you do that? Then you can just use the same idea as before. So we remember that when we first used the 1 to kill off those 2 entries, then actually what we did is to multiply that row by something and then add to those rows and change them, right? So we can do the same thing here. We need to multiply this row by something and then add to that row so that we can change the third row. But in this case, you can see that they're just opposite of each other. So you don't need to multiply by anything, or you can simply just multiply by 1 and then add to the third row. That's what we're going to do here. So well, actually, I think I have enough space right here. So I think I will just do it in this side right here. Okay, now just do row 2 plus row 3, right? I'm multiplying by 1. That's why I didn't put any number right here. And then change what? Change the row 3. So now let's put that here. So we get, right now we don't change the row 1, so we can just simply just copy it. We also do not change the row 2, right? Because row 3 is the only row that's being changed. So row 2, just leave it here. Okay, so same thing here. Now, the next one is it's going to be changed, right? So you are just going to take this row, add to the third row. So you're just going to get 0 here. And then 1 minus 1, you just get 0. Good. And then -1, -5, we get -6. And then -5, 13, we get negative 18. And then don't forget to put the bar here, which will just make it easier for us to read. Okay, so we have that. Now at this point, depending on the definition, some textbooks are saying that, okay, so all the leading coefficients must be 1, or some textbooks don't have that. So depends, right? You can also just consider that as the row echelon form. So if you want, you can stop here. You can stop the row operation. You don't need to continue anymore. And all you need to do is to do the back substitution, right? If we are just having that requirement that all the leading coefficients must be 1, then we can just do one more step, then we can turn that into a 1. Okay, so how do we do that? We multiply the all 3 by negative 1 over 6, and then we can turn it into a 1. So let's do that. Yeah, so let's do that here, which is to just multiply, right? Which is to just multiply. Multiply this by, what is that? Negative 1 over 6, row 3. Okay, so we just copy all the other stuff, right? So 1, 0, 1, and then the 4. And then 0, 1, negative 1, and then negative 5. And then the last row will change. Actually, let me just close the matrix first. Okay, so now what do we get here? 0 becomes 0, right? Actually, you don't even need to worry about the 0, so you can just copy them down really quickly. Now, this negative 6 times negative 1 over 6, we get positive 1. Okay, good. And then negative 18 times negative 1 over 6, we get positive 3. That okay? And then let me just put the bar to separate. Okay, so now you can stop here. You can stop here in general. So you may say, what do we do then? What do we do? You can rewrite this back as a systems of equation, which will now look like this. So you have x plus z is equal to 4. And then y minus z is equal to negative 5. And then z is equal to 3. And do you see that now your 3 equations, they look like this. And then z equals 3 is already given. And then what happens? We can do this back, what we call the back substitution. We plug the z equals 3 back in here, and you can solve for y, right? Plug the z back into the first equation, you can solve for x. Let's do that. So we have what? What do we have here? Y minus 3 is equal to negative 5. So y is equal to, if you add the 3 to both sides, you get negative 2. Right? Now continue with the first equation. We want to solve for x. So we have x plus 3 is equal to 4. So you can say that x is equal to 1. And so do you see that we actually have the answer right here? It's 1, negative 2, and 3. So you have the answer as just 1, negative 2, and 3. If you write it as an order triple, right? So that's just x. This is the y, and then this one is the z. Is that okay? Now, before we end the video, I still want to talk about what's going on with the Gauss-Jordan elimination. What happened is that we got to go all the way to reduce row echelon form. That's really just saying that all those entries above this one right here must also be turned into 0. So basically, that's really just one more step. And then once we get that, then you can see that the answer can be read from the matrix. So let's just do one more step right here, even though we already figured out the answer, just to explore, right? So if we do one more row operation right here, and then what do we do here? We can simply just add the third row to the second row, and then we can kill off this negative 1, right? So we can do, what do we get here? We can do row 3 plus row 2, right? We can multiply row 3 by just 1, right? And then we are changing row 2 in this case, okay? Now, what happens is that usually whichever row that you're using to remove the entries or to turn the other entries in the other rows, then that's the one that you're going to copy down first in this step. Okay, so because I'm using row 3 and I'm using the pivot in row 3, and so I should copy down that row first. It just makes things more convenient, or it feels easier this way. And then don't copy the other rows yet, right? Because I'm going to change them. So copy the one that you are not going to change, which is the row 3 in this case, and that's the one that you're using. That's the row that you copy down. And then now you add to the second row, so you get 0. Actually, because they're all 0, so you don't need to worry about changing any of those entries. You can simply just copy them. It actually gets easier at this point when you have a lot of zeros. So 1 minus 1, you get 0 here. 3 minus 5, we get -2. Oh, I actually should be using the color, right? Just let me highlight the color. So we get 0, 0. No, actually that's a 1. And then this is 0. This is -2. Okay. And then we got to do one more. There's one more that we need to worry about here, which is to do to change the row 1. And then so you can see that there is a 1 right here above this one. So all we need to do is to multiply this by -1 and then add to the first row. So we get negative row 3 plus row 1. And then remember, you're changing only the row 1. So now what do we get here? We get 1, 0. Remember, those are 0 entries, so they are not going to affect any of those entries here when you add them. So now this one is what? This is -1 plus 1, so you get 0 here. This is -3 because you're multiplying by -1. -3 plus 4, get +1. Is that okay? So now, as you can see, you're getting the identity matrix right here. This is in the reduced row echelon form. And the good thing about having this form is that you can actually see the answers immediately. So x is equal to 1, y is equal to -2, and z is equal to 3, as you can see here. So x equals 1, y equals -2, and then z is equal to 3. The bad thing is that you have to do more row operations to get to here, from the row echelon form to the reduced row echelon form. Is that okay? So this is the whole problem that we see here. So let me just show you. Right? So that's everything that we have here. Okay, I will show more difficult examples next time, and then I also want to talk about one calculation or computation trick that will allow us to avoid having to deal with fraction. It doesn't always work, but when it works quite nicely. Okay, I will show you next time. Stay tuned for that video. To help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video.